series. They both go in here. Power series are easily recognizable because you're seeing this piece right here. Okay, exponent. This could be really small, like an n, or it could be something large, like we've seen before, like an n over n plus 1, or have factorials in it, or anything like that. So the a sub n are those pieces we've been looking at, okay, over and over and over. So now to those different summations with all the n's, we're going to be adding in this piece. And that's what's going to tell us it's a power series. And it'll always be centered at C. So if I saw this in a problem, kind of make some stuff up here, that means it's centered at 2. I don't care what else is going on in there. When I find that x minus 2, it's centered at 2. If I see x plus 1, it's centered at negative 1. Everybody okay with that? If I see x, it's centered at 0. The c value is 0. Everybody okay with that? Now the reason the center, let's think about this, tie it into some old algebra stuff. Centered at 2, centered at negative 1. Remember right 2, left 1? That's what shifted the graph, or whatever you're talking about, left or right. So in this being a summation, you're shifting the series left to right. Right 2, left 1, nowhere. That's what's making those centers. So that should sound familiar. It's just old stuff you've done. Okay. What we're going to have to figure out is the radius of conversion. So it is going to converge at my center, whatever that is, okay, if it converges. It will, if the radius is 0, then you didn't go anywhere from the center. So if the center was 2 and the radius was 0, then that's all it converges at. If it was centered at 2 and the radius was infinity, then it would converge everywhere. So the radius would be if you're going to go left and right at the center. So if you went left infinity and right infinity of 2, you'd be negative infinity to infinity. That makes sense? At an interval. So that's why I'd say it always converges. If the radius is r, it's going to create what we call an interval of convergence. So let's say r equals 3, centered at 2. R is 3. Kind of make something up here. That means my interval of convergence would be negative 1 to 5. 3 left of 2, 3 right of 2. Be between negative 1 and 5. Does that make sense? Okay, so let's say C is negative 1. And let's say R equals 4. The interval would be, what's the left point? Negative 5. And the right one? 3. Are they okay there? So I think the interval is actually pretty easy to find. Once you know this value, we're just going to go left and right that amount from the center. Right? What we're then going to have to do, if we have an interval, we're going to have to determine the convergence or divergence at the endpoints. Right? So this is an interval. When we have an interval, we're going to determine convergence or divergence at the endpoint. So what we don't know, if I know C is 2 and R is 3, I know it converges between negative 1 and 5. What I don't know is they converge at the endpoints, diverge at both, converge at one of them, or the other. That's what I'm going to have to figure out. Right, so we've got kind of a process here. We're going to look at a power series. We're going to determine the center. Should be recognizable what the center is. We're then going to determine the R value. And we're going to determine that radius. Here comes that ratio test back. Determine the radius. We'll then figure out right away, is the radius 0, infinity, or is it some value? Okay. If it's some value, like a 3 or a 4, then I can set up the interval. Once the interval's set up, then I'll check the endpoints for those pieces. All right, so let's look at this first one here. let's go. Sum thing goes from 0 to infinity, 3 times x minus 2 to the n. So again, we need to determine center, then radius. So where would this one be centered at? 2. 2. Okay. So C is 2. Now I'm going to look at the radius. So in comes the ratio test. Now, nice thing is, any of our tests that we use, we're going to use the ratio test here to start. They're all ones we've already done. There's not a new test coming. So my ratio test, limit, n goes to infinity. Absolute value, 3 times x minus 2 to the n plus 1 over 3 times x minus 2 to the n. Not a whole lot going on in this ratio test, really. Not too much there. Because we're used to seeing a fraction in there to start with, and we have to invert multiply. This was just a single term. So pretty obvious here, the 3's go. And then what do I do with those x minus 2's?
They kind of cancel.
Kind of. What's left, though? Okay, we'll have an x minus 2 left at the top. Everybody agree with that? Because this would be x minus 2 to the n times x minus 2. And the m ones would go. Leaves me with absolute value of x minus 2. Now, I just have the x minus 2 there. There's no n's left, so I'm not worried about n to infinity at this moment. When did the ratio test converge? What did it have to be less than?
1.
1. All right. And you're right, the bigger than 0, but we have the absolute value to ensure that. But you're correct. Okay, so it can be that less than 1. Everybody okay there?
So how is it always less than 1?
That was the ratio test that we did.
Yeah, but like there's an x there, and doesn't x.
When does it converge? When it's less than 1. So that means x values would have to produce a value less than 1. So you're right, since an x is there, what we're saying is this thing will only converge when that absolute value is less than 1. So the only x values you can put in would have to be ones that produce something less than 1. So we couldn't have x equals 4 here. That make sense? All right. So converge is less than 1. This right here just became the radius. Radius is 1. Okay. Look what showed up right here and what's right here. Same piece coming back out.
I'm sorry, I've got a little bit of a maybe a silly question. So if you put in negative 2,000, do the negative 2,000 minus 2, which is going to give you like some really big negative number, which becomes some really big positive number.
Which is not less than 1.
Right.
So radius would equal 1. So that's going to make the interval left 1, right 1 from the center. Left 1 would be 1, right 1 would be 3. Does everybody agree with that?
Yes.
Okay, so now just think of some values between 1 and 3. Any of those would work. All right, 1.5. 1.5 minus 2 would be a positive 0.5. Hey, that's less than 1. That's the absolute value. 2.5. Hey, that would be 0.5. That's less than 1. 2 would be 0. That's less than 1. All those values converge. What we don't know is what's going on at the endpoints. Because remember, if it equaled 1, it was inconclusive.
Yeah.
It didn't mean it converged or diverged. It meant we wasted our time. We didn't know. Okay. So now we're going to go check these endpoints. So we need to determine if on each one of these 1 and 3, is it a bracket or is it a parenthesis? I got to figure out if I'm going to include them. All right? So we're going to test each value. So our process again, we determine center, ratio test, and we're going to see some values come up that aren't just 1. Just going to give you some different looks. Okay. That gives us the radius. That determines the interval. Now we check the endpoints. I check the endpoints. So we're going to put a 1 in. I'm going to say if x equals 1, now I'm looking at the sum of 3 times negative 1 to the n. And if x equals 3, I'm looking at the sum of 3 times 1 to the n. So if x equaled 1, 1 minus negative 2 is negative 1. If x equaled 3, 3 minus 2 is 1. Now comes back all of those other tests. I'm looking at those individual sums. And I'm trying to decide, does that converge or diverge? Why? The one test you don't want to try is the ratio, because it's going to give you a 1. That would be the inconclusive part, okay? But think of anything else. So I would say that this diverges. I would say that this diverges, and I would say they both diverge from nth term. The limit as n goes infinity, it's not 0. Therefore, it diverges. You could do ratio. Not ratio. I'm thinking R. Geometric. Row 1. Diverge. You can have a number of different ones.
How do you prove that the radius equals 4?
When does the ratio test converge? When it's less than
1.
That's how I knew.
So
No other way.
always going to equal 1.
The ratio test is. It will not always have a radius of 1. No, we'll look at some differences. But it will always converge when it's less than.
How did you get the interval again?
I went 1 left of 2, 1 right of 2. So it's centered at 2, and if the radius is 1,
That makes sense.
so think of a number line. I'm at 2. 1 to the left would be 1, 1 to the right would be 3.
Perfect, yeah.
There's where I'm getting that. So since they both diverge, there's my interval. So I check my endpoints, both are parentheses.
I struggle to see how it could converge. Like when you're doing the endpoints, how the endpoint could converge.
If it produced a value on another test that would converge,
You know, I'm just trying to think of.
it won't on this one.
Yeah.
You can't look at this one and say, how would the endpoints converge, because they don't.
Yeah, but I mean, like.
It depends on what the series is. Depends entirely on what the series is. Let's go to a different series. Let's go, n goes from 1 to infinity. 1 over n, 2 to the n, x to the n. Now remember, I switched from a 0 to a 1 on that bottom. It really doesn't matter. It's still an infinite series, right? Whatever value we got there. So where's this one centered?
0.
0. So remember, for your center, you look right at the x. There's no c value. There's no x plus or minus anything. So this thing's going to be centered at 0. I'm just going to put it right here. C equals 0. Because I don't have a plus or minus anything up there. Now I'm going to go to the ratio test to determine my radius. And you don't really need to write this, but usually in my notes I would write ratio test to remind me what I'm doing here. Okay. Limit n goes to infinity. This would be x to the n plus 1 over n plus 1, 2 to the n plus 1, times n 2 to the n over x to the n. Now remember, ratio test, we did the n plus 1 term over the nth term. So my n plus 1 term, I just went ahead and slid this into the numerator instead of out to the side. And then for the second one, divided by the nth, we invert multiply. So we skipped that step there. Are we still okay with that? Okay. So now I'm investigating this limit. What goes away?
The n plus 1.
All right, n and n plus 1 go. Because at infinity, that plus 1 is not going to change anything, right? What else?
2n goes, but it's
It leaves a 2 on the bottom.
All right, so I'm going to leave a 2 down here.
And X is going, you're left with an X on top.
Left with an x on top. Okay. That look okay to everyone? All right, so this is going to leave me with absolute value of x over 2. And when does this ratio test always converge? Less than 1. Now, let's kind of look back here. See how this matched up with this?
Yes.
That means I only want an x here. So wouldn't that mean the absolute value of x is less than 2? Multiply both sides by 2.
Okay.
Now I'm getting this matchup right there. But what that has now done is create a radius equal to 2. Now this thing was centered at 0. The radius is 2. So what's the interval?
Negative 2.
Negative 2 to 2. So again, picture like a number line. You're sitting right at 0. You're going to go 2 left, 2 right. So negative 2 to 2. So I know it converges between those two values. Now I've got to figure out if it converges at negative 2 and or at 2. So I can get my bracket or parenthesis there. So we check the endpoints. Just write check endpoint. Again, not something you have to write every time, but good thing to have in your notes because then you look back and realize what you did. You're just checking the endpoints. If x equals negative 2, I'm going to move just right up here so I don't get in the way of the podium. Endpoints. All right, so we're going to check endpoints. All right, so if x equals negative 2, so I'm going to substitute a negative 2 in for x. So that's going to give me the sum negative 2 to the n over n 2 to the n. And then my other one, x equals 2. That would give me the sum 2 to the n over n 2 to the n. So I'm going to investigate both of those sums. So yet all I did was substitute the endpoints in for the x. I know I moved them up to the numerator, but that's not going to change anything. Okay? So this right one, it actually quickly just goes to 1 over n. Because the 2 to the n's cancel, right?
Mm-hmm.
All right, so 1 over n. Converge, diverge, y.
Diverge, harmonic.
All right, diverge, harmonic. So diverge, harmonic. And again, whatever reason you're using on there, harmonic, p-series, integral, whatever, write it down because then you'll remember what you did. Diverge, parenthesis. Negative 2. This actually reduces down to negative 1 to the n over n. So the negative 2 to the n and the 2 to the n, that would create a negative 1 to the n. Converge, diverge, y.
Wait, hold on. Doesn't 1 to the n simplify to just negative 1 to the n? Oh, wait, no, because you don't know if it's positive.
What do you think? What do you remember?
You can do alternating series.
You can do alternating series test. It's definitely alternating. What's that? So would it converge or diverge? No, harmonic. 1 over n is harmonic, but negative 1 to the n is bouncing back and forth between positive and negative. That make sense? This actually converges. Converge. This is what we call an alternating harmonic. Alternating harmonic converges. Okay. We saw that one the other day. Now, again, you said the alternating series test. That's fine. Alternating series test. Limit, n goes to infinity. 1 over n 0, yes. 1 over n plus 1, less than 1 over n, yes. Alternating series test converges. That means we've got a bracket here. There's my interval. The best part about the power series is there's only one thing new, and it's pretty simple. The new piece is, hey, where's the center? I can see where it's centered. Okay. The other new piece is, what's the interval? Well, if you know you're going left and right that much from the center, the interval is pretty easy to create. Okay. The downfall of the power series is it's a lot of steps, a lot of work. Okay. But the ratio test isn't new. I know we're not used to always seeing a number showing up here. That's okay. We move that over. Get to my radius, sets my interval, and then when we go test the endpoints, yeah, it's some extra steps. It's a lot longer, but they're not new pieces. We're back to just using the same old things we did last week. Those pieces there.
I'm sorry, for the life of me, I can't remember which one the harmonic test is.
There's not a harmonic test. 1 over n is a harmonic series. Diverges.
Oh.
You can use p series, p equals 1. You could use the integral test on 1 over n, diverge. And what we said was, if you can remember, that's harmonic. That's one of our known series. We know that one diverges. But the test would be a p series or an integral test.
Okay. I thought it was.
All right, so let's go 3 here. 0 to infinity, -1 to the n, x plus 1 to the n, over 2 to the n. So here's our process. We're going to find center. We're going to use ratio to get radius. We're going to set the interval, test the endpoints. Where's the center? All right, center's -1. Ratio test. Because I'm trying to get the radius. All right, so as I set up this ratio test, let's think here. What is it I don't really need to put in there at all? -1, because it's going to be absolute value. Right? What am I expecting to get out at the very end? X plus 1. That's what I'm expecting to get out. Right? Let's see, we're going to have x plus 1 to the n plus 1 over 2 to the n plus 1 times 2 to the n over x plus 1 to the n. Again, I left the -1s out. For absolute value, they're not going to matter. I've got my n plus 1 term over the nth term. Invert, multiply, it's set up. Now I'm looking for what's going to cancel and what's left. So you should see a 2 that's going to be left on the bottom. And an x plus 1 that's left on the top. Yep. Yes. Does that sound good to everyone? And so this would be absolute value x plus 1 over 2. And when does it converge? Always when it's less than 1. Now remember what we said we wanted. We wanted just that x plus 1. So that means the absolute value of x plus 1 is less than 2. Move that 2 over. Ready, okay there? So now the radius is what?
2.
2. All right, radius equals 2. Interval is between what and what? -3 and 1. Now I'm going to test my endpoints to determine my actual interval. So I test -3, test 1. All right, so check endpoints. All right, let's say x equals -3. If x equals -3, I'm looking at the sum, -1 to the n, -2 to the n, over 2 to the n. If x equals 1, I'm looking at the sum, -1 to the n, 2 to the n, over 2 to the n. I'm just going to go write them out with each of my x values in there. So then I can look at each summation. I'll simplify them if I can, but then I'm looking at whether or not that particular summation would converge or diverge. So the right one looks a little easier because the 2 to the n's cancel. Not much going on over here. So this will be the sum of negative 1 to the n. Converge or diverge? What do you think? Diverge? Why? What? Which test?
Geometric.
Geometric? All right. Because R would be 1. What else could you use there? Nth term test. That would work. Just got to review the different ones that we did. Okay. Now this guy. All right. Also, wait, we said diverge. In parentheses there. All right, over here, well, this would make negative 1 to the n. We talked about that, right? So now you have the sum of negative 1 to the n times negative 1 to the n. That'd just be the sum of 1. I mean, if you have like bases, you add exponents. So n plus n would be 2n. Everybody agree? Which basically means n is always even. So you're looking at negative 1 to an even power. Well, that's always 1. Everybody okay with that? Converge or diverge?
Diverge.
Why?
Because if you just have a constant, it doesn't converge.
All right. Diverge, that would be the nth term. Because if you just have 1, it's going to be 1 plus 1 plus 1 plus 1. Parenthesis. You'll be there. Let's go sum as n goes from 0 to infinity. N factorial x to the n. Where is its center?
0.
Ratio. We go for my radius. Using my ratio test. Limit. N goes to infinity. N plus 1 factorial x to the n plus 1 over n factorial x to the n. This is one of the reasons I told you before that ratio test is usually one of my favorites because I use it a lot. I don't think it's the quickest, but I use it an awful lot. Kind of get used to it. All right. What goes, what stays here?
So on the top, the x, the n cancels, we can just x.
All right.
And the factorials cancel, leaving an n plus 1.
Where?
On the top.
On top. Okay, so n plus 1 left on the top. Now take out the rest of the factorials because it was really this. So now we're left as the limit. N goes to infinity. Absolute value, n plus 1 times x. Now, I know in the last few I haven't rewrote the limit over here because there's no more n's left. This time I've got an n left, so I wrote that n in there. Right? So what would the limit as n goes to infinity times x equal? Infinity or? Can't be negative, it's absolute value. But you're right, if the absolute value wasn't there, it'd be negative. Somebody said it. When 0.
Oh.
It's easier than you think. If this, all right, if this was going to equal 0, what would x have to be?
0.
0. And it'd be infinity if x wasn't 0. Everybody okay there?
Yes.
All right. So this would converge only when x equals 0, which means no radius and no interval. That's the only place it converges.
So it seems to me like it always does that when there's still an n left at the end.
Not if the n was on the bottom,
Not if the n was on the bottom.
Because that would be 0.
because then it would always be 0. So if the n was on the bottom, it would produce an infinite interval. So you'd have this guy. Radius would be infinity. The only way that that's going to stay less than 1, we're guaranteed to stay less than 1, is if x is 0. So that put us to right here, only converges at c, which in this case, c was 0. You okay there? All right, so you're going to, what's the first thing you do?
Find your center.
Center. Then what?
Ratio.
Ratio gives you the,
Radius.
which gives you the,
Interval.
then what do you do?
Check the x-rays.
Simple enough, right?
Yeah.